Hi guys, I wanted to do a quick review of similar right triangles for you guys. So in this review, I want to show you guys two methods for solving these, okay? So two different methods. One is going to be what we learned in class. This is the way I have found most people like better, but there is another way, a shortcut way, that some people prefer. So I'll show you both. You guys can decide. First, these problems come in two types, all right? There's type 1, and this is where we've got like this inside sort of way, okay? We've got like the altitude and the hypotenuse of the largest triangle, all right? Then there's the second type, which is this type where we're working with values around the triangle and we do not have the altitude. So in type 1, altitude is involved. And in type 2, we're only going around, no altitude involved. Okay? So in the first method, it doesn't matter which type you have. All you do is separate the triangles, label, proportion, and solve. Okay? So let me show you what that looks like. So first, we draw a triangle that looks just like this one. The largest triangle. And then we draw two more, each getting a little bit smaller. And then we start labeling it. So for example, the right angle is right there on the top. I'll put it right there on the top on each of these. And then, let's zoom it in a little. We're focused on this one right here right now. Okay, then I want to start labeling the other stuff. So I'll go to the triangle and I'll label this guy as the blue angle. So that makes all of these my blue angle. So they're in the same exact spot. And then I'll make this my green angle. These are looking so thin. Why are they so thin? It's because I'm zoomed in. I'll just make it a little thicker. Okay. So then I'll go and label each of these as the green. And then in here, each one of these three triangles needs to have the red right angle. Each one needs to have the blue single arc angle. So right now the smallest one has it, great. The medium one doesn't. Well, there's its red, there's the green. That means the blue must be up here. And then the tiniest triangle has the red, has the blue, but it's missing the green, which means it's here. And now that I've got these all labeled up all around, I'm going to use it to bring these values that I've got here down here. So the hypotenuse is 25 on the largest triangle. Across the right angle is 25. That goes here. That 9 is across the green angle on my smallest triangle. So smallest triangle across the green is 9. And then on the medium triangle, I've got x is across the green. So across the green is x. Now you may see these in different order, it doesn't matter. X is also part of the smallest triangle and it's across the blue angle. So across the blue and the smallest triangle is x. And then now, this is looking a little blank, but you guys always look for additional information. For example, if this piece is 9 and the whole thing is 25, I can subtract 25 minus 9 to get that this side right here is 16. I can figure that out myself, all right? So 16 is across the blue angle on the medium triangle. So that was separating the triangles and labeling. Now we set up a proportion and we solve, all right? I see that, let's see, how do I do it? I see that x can go over, I went too far. X can go over 16, and 9 can go over x. You may have seen a different proportion. That's okay, as long as you stay consistent. And as soon as we cross multiply, whatever other proportion you chose, we should have the same answer if you did it right. So x over 16 equals 9 over x. And now I'll cross multiply and solve. So x times x is x squared. Cross multiply. And 16 times 9 is 144. Then square root both sides. And we get that x equals 12. Okay, that was method 1 on this guy. Now let me show you method 2 on this guy. Method 2 is a shortcut that's just kind of learning the way these patterns go, all right? So for method 2, I call this the shortcut. And this one, for this type of problem where the altitude is involved, I call it the rainbow. Here's how it works. When we have these triangles, that is a really bad start to this triangle. There we go. And then let's go like that. And then let's go like that. All right. This is the right angle. And then I'll draw the altitude. And then I'll get this angle, this angle. Okay. For the rainbow, this is what I see. We need this side. Okay. So you could see they gave us that side in this problem. We need the altitude. So you could see the altitude was our unknown value we were solving for in this one. And then we also need this little side right here, which this problem that we were doing didn't straight up tell us, but we could find it by subtracting. So what we're going to do is the rainbow. We're going to go this guy, the blue, over that guy, the red, equals this guy, the red, over this guy, the green. So here's what that'll look like when we set up our proportion. It'll be the blue side that I kind of colored over the red side equals the red side again. So you see there's an arrow going to the red side, which makes it the bottom of this ratio, but there's also a line starting at it. So it's also the top of this ratio over the green. Okay, so what would that look like for this problem? It would look like this. Let's see if I can do this. Up. Nope. Yeah, this one. No. Okay. Never mind. Can't do it. I will just draw it. So, in this problem, which I'll just recopy, and then they gave me 9, they gave me 25, and they gave me x. I'll do 25 minus 9 to get 16 here, and then I will do the rainbow, all right? Which means I'll go from 9 over x equals And then I'll go from x to 16, the rainbow. Do you see the rainbow? Rainbow. So x over 16, okay? We get a ratio slightly different than here, but remember, after we cross multiply is when we decide. So we cross multiply, and we get x times x is x squared equals 9 times 16, which is 144. So as soon as we cross multiplied, we got the exact same thing. Square root both sides, x equals 12, all right? So this was how to do method 2. If you remember and learn this rainbow pattern that occurs in these triangles, and just go this side over the altitude equals the altitude again over this side, all right? So there we are. Okay, now I told you guys there's 2 types of problems, right? So on type 1, altitude involved, these were the ways. Here's type 2. In type 2, we know values going around the triangles, but not inside, not the altitude. Okay, method 1 still always works. Okay, that's why I love method 1. It still always works. You separate triangles, label, proportion, and solve. All right, so here we are. We'll redraw this guy. And then we'll do 2 more, each getting a little smaller. I hope you guys are feeling good about your triangle drawing skills because it's not easy for anybody. All right, so here we go. Let's go marking some angles. Here's the right angle. And then let's go with, this is the blue angle here. This is the green angle here. And then everyone here needs a blue and a green, so there must be a green there, and there must be a blue there. And now let's go label. So the X is across the right angle on the medium triangle. The 45 is across the green in the medium triangle. The 81 is the hypotenuse of the largest triangle. And then it appears did I have nothing else? No, I can't have nothing else. X is also the leg across the green angle in the largest triangle. Now, I can see here that I've got enough to make a proportion right now. But if I wanted to, I could subtract 81 from 45, get this side, and just to see what else I find. But I don't need it in this case. So here we go. I can go 45 over x equals x over 81. And if you saw a different relationship, as long as you get the same thing after we cross multiply, you are right. So 45 over x equals x over 81. And then we get that, we cross multiply. And we get x squared equals, okay, 81 times 45. I don't know what that is, you guys. Here's what I'm going to do, because I don't have a calculator. But if you have a calculator, you can multiply them. The thing is that it's not going to come out to be a perfect square. So even if I did multiply and I got this big number, the first thing I would do with that big number is break it down into 2 factors and do a factor tree. So in this situation, I'm just going to do the factor tree. This is 9 and 9, and this is 9 and 5. And my 9s are 3s. And my 5 is done. Then looking for pairs, I've got all those pairs, and then I've got the lone 5. So this is going to equal, the square root of all this is going to mean that x equals a 3 times another 3 times another 3 times a radical 5. So x equals 3 times 3 is 9, 9 times 3 is 27, radical 5. All right, so that was us doing method 1. Now let me show you the shortcut method for this. All right, this is method 2. I call this the shortcut way, and the name I have for this one is Cinderella's carriage. Because that's what it looks like to me. So let me show you what I mean. So first I'll draw the triangle, all right? Okay. We've got the right angle right there. And then we've got the altitude. And then we've got these right angles here. Here's how it works, all right? Here's the relationship. The relationship is this side, okay? So this guy right here over that side will equal, again, this side. So remember, these are geometric means, and that middle one will always repeat, over, now here's the tricky part, over this entire side. Okay? So I put the dot right in the middle so that I know it means this equals the whole hypotenuse of the largest triangle, not the left piece, not the right piece, but the whole thing. All right, so here's what we get with that. We get this blue side over the red side equals the red side over the entire hypotenuse of the largest triangle, which in this case I made the green right there. Now, it's true for the left side. The right side is the same thing, so it's true for that side as well. So we can also do this side the same way. So it's also true that this piece over this piece equals this piece over this whole leg here. The whole hypotenuse, I'm sorry, I called it a leg. The whole hypotenuse, the entire length there. And this looks like the pumpkin carriage Cinderella rides in to me. So this is Cinderella's carriage. So let me show you what it looks like now. Applying this shortcut method to this problem would look like this. Now I only need in this problem the left side of this carriage. I don't need the right side of this carriage because everything I'm working with is on the left side. All right, they gave me 45 right here. They gave me X right here. And then they gave me the entire thing is 81. Let's say they didn't straight up give it to me, but they gave me that length. Then I can add them to create the whole length that I need so that I can use this. So please keep all that in mind. All right, here we go. Let's do the carriage, all right? The carriage says that this piece 45 over that X equals this X over the entire side, which is 81. So equals X over 81. So you can see that that gave me the same ratio. But even if it hadn't, I wouldn't judge it until after I cross multiplied. So I'll cross multiply and I'll get that x squared equals, again, 45 times 81. I don't know what that is. Thea, what's 45 times 81? I'm curious now.
3645.
3645. Okay. So that's what that equals. And I just want to show you what I meant by there's no need to multiply. Now that I square root both sides, I need to do a factor tree on 3645. And you may go picking different numbers, but I remember that it was 81 times 45. So the first thing I'm going to do is break it into 81 and 45. And now I'm where I was when I was doing this problem. Anywho, I know how this factor tree goes. It goes 9 and 9. It goes 9 and 5. 3, 3, 3, 3, 3, 3, and that 5 because we did the exact same thing here. X equals 27 rad 5. And there's your two methods to do the two different types of these special right triangle problems. You are welcome to do whichever method speaks to you.